All right. Again, back to implementation. Okay, I put it at the last. I don't know why. We can actually have two ways to implement a tree. First is via an array-based implementation where the elements are stored basically in an array. Okay. Again, array is more efficient when we know the index that we want to write or read. Okay. But if we don't know, that means if we don't know the index, that means we have to scan all the elements. Kaya siya inefficient naman for reading. Okay. But again, if you know the index, then that's fine. That's an O of 1. So the parent-child relationships are derived from the indices. Okay, so if we have P as the parent index, then 2P is left child index and 2P plus 1 is the right child index. So again, if we want to implement this tree, okay, pen 20 will be placed at index 0 since that's our first entry. We fill in the first left child first, which is 18, so it goes to index 1. Then the right child, which is 22. If we want to add more on the 18, let's say we want to add 25 and 30, we simply have to add it at the end of the array. So this will be 25, this will be 30, and this property follows. So 2P, if the parent is P, so the parent is P equals 1, okay, then the left child index is a 2P. Teka. This was supposed to be correct yesterday. Hang on. Okay, I get it now. So this is not supposed to be 0, 1, 2, 3, 4, 5, 6. This is supposed to be 1, 2, 3, 4, 5, 6, 7. Right? I'll just correct it on the PDF. All right. So again, if we have, oops, not here. So here, P is equal to 2. Okay. Then the left child is 2P, which is equal to 4, which is 25, correct? And the right child is 2P plus 1, which is 4 plus 1 equals 5, 30, which is correct. Okay. Now, if we want to add more items, if we want to add more child nodes for 22, let's say we have 15 and 19, then we simply have to add the array. So we have 15 here. And then may sakit, annotate. 15 and 19. Okay. So the parent node is 3. The left child is 2P, which is 6. The right child is 2P plus 1, which is 7. Okay? And so on and so forth. Now, if we want to know what is the parent child or parent node of one specific node, we simply have to do a integer division of 2. Okay? So let's say if we are at index, so if we want to know the parent of node 19, and we know 19 is at index 7, then the parent is at 7, integer division 9. Okay, so again, integer division, so ito-drop niya yung remainder. So a 7, sorry, not 9, 7 integer division 2, which is equal to 6. Wait, mali na naman ako. Equal to 3. Okay, why? So 7 divided by 2 is 6. Okay, just to remind you with integer division, 7 divided by 2 is equal to 6 remainder 1 is equal to 3 remainder 1. Ano nangyayari sa akin? 3 remainder 1. And integer division drops the remainder. Okay, so that means we arrive at 7 integer division 2 is equal to 3. Okay, and to do integer division in Python, just have to do double slash. So madali. So it's easy to navigate where the parent node is and where the children nodes are. Okay. So if you can also do it via linked implementation. So again, you can store it in an object tree and define the left and right nodes of that specific subtree. Okay, this is what I've explained earlier on the first half of this lecture. Right? Any questions so far?
None for me.
Right. So I want you to remember at least this part, the array-based implementation. For the next lesson, for the next hour, we will actually leverage on this array-based implementation. Okay. So as you can see, if we do it on an array-based implementation, we are already filling in the left child first. Okay. So from here, from 18, left child muna, then 22. And then if we insert 2 more items, we are first filling in the child of 18 before the child of 22. Okay, so we are already building a complete tree when we are enforcing. Okay, basically array-based implementation enforces a complete tree structure. Okay. Again, bakit? Okay, every entry of an element to the array goes to the left, fills in the left child first. Okay, so 18, 22, and then pag pasok ng 25 and 30, automatically na-assign siya kay 18, and then 15 and 19 kay 22 muna. So we did not leave any space in between just to assign 15 and 19 to 22. Okay, so nauna si 20 and 30, and then 15 and 19. Okay, so array-based implementation enforces a complete tree structure. Okay, so that ends this module, okay, on trees. And let's take a break, maybe a 10-minute break for you guys to get some food, water, juice, coffee, whatever. Okay, and we'll discuss the next module after this. All right, so I'll see you. It's already 1 o'clock, 12:59. So 1 o'clock, we'll be back at 1:10. All right, I'll see you guys at 1:10.